Go and open your book to page 517. Okay. Today's lesson is on how to use the degrees to measure angles on trigonometry. So this chapter is on trigonometry. Now trigonometry, if you look on page 516, look at the paragraph. It says trigonometry can be used to find distances that cannot be measured directly. Engineers need exact values for such distances to complete a large-scale project like the bridge shown above. Okay, so again, trigonometry is used to measure something that you cannot measure directly. An example of here is you building a bridge across a river. Obviously, you cannot just get a measuring tape and put across the river and measure the distance, right? Okay, so that's why you need a trigonometry to calculate. And for example, like the distance from the Earth to the Moon, okay, how are you going to measure that? Obviously, you cannot get a measuring tape and measure, right? So you can use a trigonometry, okay, combined with the astronomy, and you can measure the distance. So trigonometry is used to measure anything that you cannot do it directly. Okay, now, but first, let's go over how to measure the angle. So when you have a circle, and if you start over here, you go around the circle. So one circle is 360 degrees. Okay, so one circle is 360 degrees. So 1 degree is like very tiny. That is like, this is like, this is even just a little angle like that. That's more than 1 degree already. Okay. Now, if you look on the clock, each number on the clock, right? There are 12 numbers. So 360 degrees divided by 12 numbers. So that will give you 30 degrees for each number. Okay. So if you want to have an idea what the degrees looks like, just look on the clock. Each number on the clock is 30 degrees. Okay, so that will give you a better concept of the degree. Now let's look at some of the terms. So when you have an angle, normally you start over here and you just kind of go like this. So this is called initial sign because that's where you start, and this is called a terminal sign. Terminal means the end, right? So you start over here. So start is initial. That's where it begins, right? The word initial. If you don't remember which is which, just use your language scale, right? Again, initial means start, right? Beginning, right? So this is a beginning sign. Terminal means the end, right? That's why if you're terminal ill, that means your life is going to come to the end very soon, right? So that's what terminal is, right? And again, if you go to the airport, you go the terminal, right? That's where you get off the airplane. When you get off the airplane, you go to the terminal. That's where the end. Okay. Okay. Now keep going, and you have the positive angle and negative angle. So if you're going this direction, this is positive. If you're going this way, it's negative. And now go down to the bottom. So the next phrase you need to know is the standard position. Standard position is when you're starting right over here. Okay, that's where you start. So this would be in a standard position. If you start something like, if you're going like this, okay, so this is not in a standard position. So standard position is when you start over here and you can go either this direction or this direction. The next term is called a quadrantal angle. Quadrantal angle is when the terminal side is on the quadrant. So like if you have like over here, like 90 degrees. So 90 degrees would be a quadrantal angle, or 180 or 270. So those are quadrantal angles. Okay, now let's go to page 518. On the top, you have a term. It says coterminal. Coterminal angles means the two angles have the same beginning and the same end. So for example, let's say if you have 120 degrees. Okay. Now the coterminal example of that would be if you go around the circle one extra time, so if you go like this, okay, so every time when you go around circle, it's 360, right? So this one would be 480 degrees, right? So to get coterminal, all you have to do is keep going around the circle. It means you keep adding 360 or minus 360. So another example, so all these are coterminal because you begin at the same place and end at the same place. So instead of going this way, I can go this way instead. So this would be negative 240 degrees. Now how do I get that? Well, you use your original angle. Again, remember, to get coterminal, all you have to do is keep adding 360 or keep minusing 360 because you keep going around the circle, right? So if you go backward, technically if you go backward, you minus 360, you end up with 240, right? So basically this is what you do. You start, so you just, over here, right, you just kind of go around this way, go around one circle, and that's how you end up with that. So again, coterminal means you have the same beginning, same end. And to get coterminal angle, you just adding 360 or minus 360. So another coterminal, you can keep adding 360. You keep adding, keep going around the circle. You can keep adding. So there are infinite number of coterminal angles. So if you add another 360, you get so 480. If you add 360 more, you get 840. Okay, so you keep adding 360. So all these are coterminal angles. And the reason you add 360 because you go around the circle one more time, right? You just go around the circle. You can keep going as many times as you want, right? Okay. Again, every time you go around circle one time, you add 360. Okay. So again, coterminal is super easy. Okay, so let's go to example 1. Example 1, it says give a formula for the measure of angle coterminal with a 45 degrees. So here's your 45 degrees. So you want to find a formula. Okay, so again, it's very easy. That's what you start out with. And to get coterminal, you keep going around the circle, right? So it would be plus n times 360. N is how many times you go around the circle. And it can be negative if you go to opposite direction. And so again, n is how many times you go around the circle. And 360 is 360 for each circle, right? And so that's your formula. Okay, so again, n is how many times you go around the circle. So if you go around one time, then n is 1. If you go around twice, n is 2. Okay, and so forth. Okay, let's go to example 2. Example 2, it says convert. Okay, so A. You need to know how to convert so you have 17 degrees, 48 minutes, and 54 seconds. So this is called the degree, minute, second formula. So DMS, the degree, minute, second. And you want to convert to decimal degrees. So to do that, you do this. So 17 degrees plus, now these are just, so this is just like the clock, the time, the same thing. So degree is like an hour. Minutes would be like a minutes on the clock. Seconds is like seconds on the clock. So if you're going to just, again, think about the clock, right? So if you're going to convert 48 minutes into how many hours, you divide by 60, right? So 48 divided by 60. And because there are 60 minutes in an hour, so same thing, there are 60 minutes in a degree. Okay, so, and then do the same thing. So 54, you have to divide by 3,600. Okay? Because you have to divide by 60 to convert to minutes, and you have to divide by another 60 to get into degree. That's why it's 3,600. And use your calculator, you punch in, and you get 17.815 degrees. So this is called a decimal degrees. So decimal degree. This is degree, minute, second. Now, on the calculator, you would do this directly. You would do this for you on some of your calculator. If you look it over here, so if it converts from decimal degree to degree, minute, second. Over here, it converts the other way. So you can use it on your calculator. Okay. So again, after we're done with the lesson, I can come and help you guys with the calculator. Okay. Now let's go to part B on example 2B. So 2B, you're going to convert it back. So you got 42 degrees. So you got 42.658 degrees. And you want to convert this into degree, minute, and seconds. So this part, so this is going to be 42 degrees already. And then from here, right, what you need to do, you have to use calculator. You're going to use 0.658, and you have to times it by 60 to get the minutes. So you're just going backward. Okay, so 0.658 times 60 equal, so this will equal to 39.48 minutes. So you take this part over here and you put over here 39 minutes. Then you have to use the 0.48 minutes, you have to convert into seconds. So 0.48 minutes, you times it by 60 to get into seconds. Okay, so it's going to be 28.8 seconds. So it'll be 28.8 seconds. Okay, so again, I will come and help you with your calculator as we start to do the assignment. Okay, so now let's go to page 521. Okay, and let's go and do number 52. Okay, number 52, it says find the first quadrant angle theta for which an angle 4 times, so you're looking for theta, okay, when 4 times, so you just write 4 times, right? So you're looking for angle, which when it's 4 times as large would be in the given quadrant. So this is the third quadrant, okay? So third quadrant is right over here. So it's going between 180 and 270. So that means you have to be greater than 180 and less than 270. That's what the third quadrant means. Okay? So now to solve for theta, you divide by 4, right? So dividing by 4. So theta would be, you can use your calculator, you punch in the numbers. And so okay. Okay. So you can use your calculator and punch in a number, and that would be your answer. Okay. And you don't have to worry about the coterminal. Just look at your primary. That's good enough. Now let's go to number 62. Okay. So again, find the angle theta. So that's your theta, in which an angle 1/5 as large. So 1/5 as large. So 1/5 of the theta would be in a given quadrant. So it'd be third quadrant again. So third quadrant is going to be 180 and 270. Okay, so again, to look for theta, you need to go and multiply by 5. So you got 900 and okay, and that's it. Okay, so basically just read and translate and get your inequality and you solve. Okay. Okay, so let's go and do some practice. Okay, so that's